Now that we've created our machine setup or changed the machine setup, we can go back into Mastercam and we can start creating toolpaths. I'll go to my toolpath manager, and what we're going to do is we're going to use the OptiRough toolpath to machine away the majority of the material, and we're going to use a 1/2 inch 3 flute flat end mill to do that. If I go to the project page in Canvas, I'll follow along. It says the below images and instructions are to be used as reference while programming the left and right side roughing toolpaths using a 1/2 inch flat end mill. So here we have an image of a toolpath manager with those two toolpaths already created. It shows us some information, the tool that's being used, the geometry, the faces that are being selected or the items that are selected to drive the toolpath, and you'll see that there's a containment boundary for the left and the right side. Here it says create a rectangular shape that measures 4.75 by 3.65 and place it as shown in the image below. The Z location is located at the center of the part material. This boundary will be used to control the movement of the 1/2 inch diameter flat end mill. This containment boundary will be used by both roughing toolpaths as shown in the image above. So both of these toolpaths will be using the same containment boundary. So what I'll do now is I'll draw in this containment boundary. I'm not going to draw in the dimensions. These are for reference purposes for you to create this containment boundary. So 4.75 by 3.625, and then you can see it's offset 100th or 0.1 inches from this 2.5 diameter surface. So inside of Mastercam, I'll go to my level manager. I'm going to create a new level, and I'll call it containment boundary 1/2 inch flat end mill, or something that makes sense. So to create a new level, add a new level, give it a name. Containment boundary, or how about boundary? 1/2 inch flat end mill. I'm going to look at the view, or look at my part from the top view, and my current coordinate system is the left face. So I'm looking normal to the left face coordinate system, or perpendicular to it. I'm going to draw in this rectangular shape, and I'm going to set my construction plane to 2D. And I like to use the rectangular shapes tool when creating rectangles like this. So I'm going to go to wireframe. Under the rectangle tool, you'll find rectangular shapes. Set the origin to the right middle. For the width, 4.75. I'm striking the tab key, 3.625. Once I hit enter and move my cursor into the graphics area, I'll see a preview of that rectangular shape. Now we need to offset it 100th out to the right of this surface. A quick way to do that is to hold the shift key down and let your cursor lock onto the origin. Left click, and now if I hover over this x-axis control, I type in 0.1, enter once, enter twice, enter a third time, and then if I hit the green check, that coordinate system is created. You can see that it's offset. And if you want, you can double check your work. Just go to the Home tab and go Analyze Distance. From the center to the midpoint, now I have my snaps turned up, or perpendicular, midpoint will work. I've got 0.1 or 100th thou. I'll select OK. If you want to double check the length and the height, once again you can go to the Home tab, Analyze Distance, and if you select opposite corners, you can see that the delta x is 4.75 and the y is 3.65. So correct size, correct offset value. So at this time I'll select OK. You could change the color, shift select, and then under the wireframe color you could go to right click And then from the wireframe color, you could change it to something different. And I'm going to try and match what I'm seeing on the project page. So that looks good. The next thing that we're going to do is we're going to start creating the toolpath. We're going to use the OptiRough, it's a 3D toolpath. And there are settings that we're going to match that are provided on the project page. So we'll create the toolpath, we'll select the geometry, and then we're going to match our settings to what is provided on this page. So back inside of Mastercam, I'm going to go to toolpaths. In the 3D section, I'll select OptiRough. If you don't see it, expand the gallery, and then you'll find it somewhere down here. So OptiRough, and it wants us to select the geometry that's going to drive this toolpath. So what I'm going to do is I'm going to hit the select icon, and because I have other things in the way, I'll go to my level manager. Now you can do all of this while you're still in the toolpath settings. So going to level, I'm going to make the material level invisible. I could make the HRT geometry invisible for the time being. And now you can triple click on the part. The entire part becomes selected. You could also hit Control A at this time, I believe. And even though I selected the containment boundary, it's not a surface geometry, so it's not going to drive a 3D toolpath. So I'll select End Selection. I've got 82 items added to this list. I'm going to intentionally leave 0.02 on the walls and 0.02 on the floor. If I go back to the project page, we can double check that. And I am getting ahead of the game a little bit, so you can see here I have 84, 20 thou, and 20 thou. And slightly different entity count, and that's okay. We've got the entire part selected, this will work. From here, go to toolpath control. And if you reference the image that's provided on the project page under toolpath control, you can see that there's one boundary, and then we're compensating to the center. So match your settings to match what you see here. So for the boundary chain, we've created the boundary chain. Select this icon. That will now allow us to select the rectangular shape that we are using to define the boundary. I'll change over to C-plane. Selection method is chain. I'll select one of the lines that represents the rectangular shape of our boundary. I'll select OK. For the strategy, it's grayed out here. We're going to change over to center. And we're going to have to keep it set to stay inside. Okay. From here, we'll go down to tool. And at this time, we don't have any tools added to our tool list, so we're going to add a 1/2" flat end mill 3 flute. You can right click in this field, or you can select the select library tool. That brings up my tool library. I'm going to use a filter to isolate just the tool that I'm looking for, so I'll go to filter. And you can see my filter is active. There's a check here. I'll start by deselecting all tool types and then select flat end mill. Set the tool diameter equal to 0.5. I'll hit enter. And at this time I'll select the green check. I've got one tool that fits that description. It's tool 290. When I double click on it, it should be added to my tool list as tool number 1. Now your default workpiece material does not exist. I'll select OK. And at this time I'll just select aluminum inch 6061 again and green check. we're going to need to edit the default tool definition. So once you add the tool to your tool list, right click on it, edit tool. We want to make sure that the length of cut is going to work for us. So my cutting length is 1, so it's 2 times the diameter. That works. I'll select next. This will be a 3 flute flat end mill, so I'll set the number of teeth to 3, or the number of flutes to 3. And I like to turn the coolant on at this level, so I'll select show more options. I'll select coolant, and then I'll set the flood coolant to on. And if you turn the coolant on at this level, all following tool paths that use this tool will have the coolant turned on automatically. So from here I'll select finish. I'm going to use an SFM of 400. This is not RPM, this is my SFM. And I'm getting a cutting speed, I'm getting a RPM of 3056. And then I'll set my FPT, my feed per tooth or my chip load per tooth, to 1% of the tool diameter. So 0.5 the diameter of the tool times 0.01. And then I like to set my plunge rate to half the calculated feed rate. So the calculated feed rate is 45.84. 45.84 divided by 2. And that should take care of all of the settings that we need to make. On this page, we are going to add a comment, so I'll reference the project page. I'll go down to the tool, and the comment is the tool name, rough left face. And I use all caps because they're going to get converted to all caps when they get sent to the NC file. So 1/2 inch flat end mill, rough left face. I can copy this information, paste it in this field, comma, all caps, rough left face. From here, I'm going to go down to stock. And what we're going to do is we're going to use the stock from the stock setup to tell Mastercam where the material is still at. Now, what I didn't do is I didn't create the stock model that allows us to identify the stock and its shape at this level. So I'm going to need to backtrack. I'll select OK. I'm exiting the toolpath. It's generating the toolpath. Go back to the toolpath manager. We're going to insert a stock model. I'm going to need to hide that for the time being. We're going to insert a stock model prior to this toolpath. The insertion arrow is currently at the end. Bring it up 1 level, so I'll use this red arrow, this red up arrow. I've got the insertion arrow now in front of the existing toolpath. From the toolpath tab, select stock model. Let's name it raw stock. For the initial stock shape, I'm using a stock model, so I'll select stock model. And actually, I'm not using a stock model, I'm actually going to use the model. So select model, and then select this icon. This will allow us to go into the session of Mastercam and pick select the stock or the solid model that represents our material. So I'll go to levels, I'll make the material level visible again, and then I'll select the solid model that represents my material. And I have to triple click. Make sure you triple click so that you select the entire solid model. Otherwise you'll just have a cylindrical face. Hit end selection. And for the initial stock model, this is all we need to do. So I'll select OK. And it rotated it 90 degrees. The reason being is I did not use the default top plane. So where it says stock plane, deselect that. I want this set to top. Now I'll select OK, and it should line up with the stock model that represents, or I should say the solid model that represents our raw material. I'll need to regenerate both tool paths. But before I do that, I'm going to regenerate just the stock model. So regenerate all selected operations. I didn't need to regenerate this one. So from here I'll go into parameters. I'll go back to stock. Now I activated rest material, and for the previous operation set it to one other operation, and then select the stock model that we just created. So we activated rest material, previous operation, we selected one other operation from this drop down menu, and then we selected, you see the green check next to the stock model that we just created. From here, go to cut parameters. We're going to match our cut parameters to what we found, or what we find on the project page. The cutting method will be climb. For the step over distance, the default is 50%. This is 50% of the tool diameter because we're going to utilize a greater length or a greater amount of the cutting length. I'm going to reduce this to 15%, and then I'm going to set my step down to 100, and in some cases, depending on how rigid the setup is, we can actually go to 150, even possibly even 200%. So we'll start with a 100% step down, and then we will have a step up of 10%. So I'm going to match my settings to what we see here on this page. Step over distance, 15%. Step down, 100%. And I'm going to set my step up to 10%. And everything else matches minimum toolpath radius. I'll just match mine to what's on the project page. From here, we'll go to steep shallow. On the project page, we're going to activate minimum depth and maximum depth. And the maximum depth, we're going to go slightly below the center line of the rotary. Once again, you got to remember that Z0 is at the center of the rotary. So maximum depth, detect limit, and then I'm actually going to set this to the radius of the tool. I'm sorry, the radius of the material, so 1.25. And then for the maximum depth, I'll match it to what I see here, minus 0.04. So we're going to go slightly below the center line of the part, so minus 0.04. So now my settings match what I see on the project page. The next thing we'll do is we'll go to linking parameters. We'll match our settings to what's on the project page. Clearance plane of 2 inches. Here we're using full vertical retract. Percentage of tool diameter is 500%. And the back feed rate, we have it set to 400. So 2 inches clearance plane, full vertical retract. Linear entry exit 0.025. Percentage of tool diameter is 500%. And then we'll set the back feed rate to 400. That should take care of all these settings. From here, we're going to go down to planes. And everything should be referencing the left face. So the working coordinate system will be left face, the tool plane will be left face, and then the construction plane will be left face. From here, I'll select OK. Mastercam needs to regenerate the toolpath. Once it's done regenerating the toolpath, with just this toolpath selected, I can run backplot and we'll get an idea of what the toolpath is going to look like. So it looks like it's going to do it in 3 depths of cut. and then it's going to step up 50 thousandths. And the reason we have this containment boundary is because we do not want the tool to collide with the jaws of the chuck. If I go back to the level manager and make the HRT 160 visible again, it's taking a moment. So what we see, these lines and these arcs represent the center line of tool, and we need to control the position of the tool so that we don't cut into the post that we're holding onto, and so that we don't run into the jaws of the vise. And it looks like we're keeping a good distance. So from here, I can exit backplot. I'm now going to run this in Verify. And inside of Verify, I would like to have the rotary, or the HRT 160, part of the verification process in case there is a collision. So what I can do is I can go into Simulator Options. So I'll go to the Toolpath Manager, Simulator Options, and for the fixtures, we can identify a fixture by the level. So I have all of the HRT 160 components on one level. So select levels, then select the HRT 160 level, and then select OK. From here, I'm going to save my work. And now with just this toolpath selected, I'll run Verify. It's going to open up a second window. And when we're inside of Verify, when we use Verify, make sure that you use collision detection collision, or stop condition collision. And if there's a crash, there's a good chance that it's going to turn up with or inside of Verify at this time. So here's my tool, here's my workpiece. Here's the HRT 160. I'll select play. And it did its first depth of cut at 100% of the tool diameter, so half of an inch. And then it steps up. And if I look at it from a front view, you can see that the toolpath goes below the center line of part by 40 thousandths of an inch, and we control that with our steep shallow settings. So this looks pretty good for our first roughing pass. And what we'll need to do next is we'll need to rotate the part 180 degrees and rough out the right side of the face. So at this time, I'm going to exit Verify. I'll go back to the project page. And it says the images above are for rough machining the left side of the knife. The T-plane that is referenced for the above toolpath is left face T-plane. To rough machine the right side of the knife, copy the proven rough left face toolpath and paste it after the original toolpath. Change the description in the comment field of the tool page and change the T-plane as shown in the images below. So what we're going to do is we're going to copy this toolpath. Right click on the toolpath, from the flyout menu select copy. Place the insertion arrow at the very end, so I'll use the red arrow down, and then position your cursor on the red arrow, right click, and paste. We're going to use the copy toolpath with a few minor changes to machine the right side, or rough machine the right side of the knife. We'll need to do two things. We'll need to change the description under the tool page, and we'll need to change the tool plane that this toolpath is referencing. So go into parameters, and planes was the last thing that I adjusted, so that's currently selected. I want to leave the working coordinate system set to left face, and I want to change the tool plane and the construction plane to the right face. This working coordinate system set to left face has established A0, and when we change the tool plane and the construction plane to the coordinate system that's rotated 180 degrees, it's going to call a A180 inside of our NC file. So I'm going to select this icon. From this menu, I'll change over to right face. Green check. I can now carry this information over to this field by selecting this double arrow. So that takes care of the plane for the right side roughing toolpath. Go up to the tool, and in the description field, change the rough left face to rough right face. And I want that to be all caps. From here, I'll select OK. Mastercam will need to regenerate this toolpath. If I go back to Canvas, just to verify what we did, planes, right side rough toolpath. Leave the working coordinate system set to left face. We did that. Change the tool plane to right face. Did that. Change the construction plane to right face. We did that. And then for the tool plane, right side rough toolpath, verify that all settings are the same as the previous toolpath. Change the comment to the rough right face as shown below. From here, we'll go back to Mastercam. This toolpath is done regenerating with just this toolpath selected. I'll run backplot. I can toggle my view just to get a better view. And you'll notice that the part doesn't move, but the tool is now approaching from the other direction, 180 degrees. And it's using the same containment boundary, it's using the same geometry that we selected for the left side roughing toolpath. Everything appears to be decent. I don't have any over travel into the hard jaws of the vise. So that looks good. I don't see anything that can be a problem. From here, I'm going to select both roughing toolpaths. There's a green check next to both of them. I'm going to save my work, and then I'll run verify again. Once again, inside of verify, make sure that stop condition collision is turned on. I'll select play. I'll speed it up a little bit. You're not going to see the rotary index, but what you will see is the tool approaching the part from the other direction. Now it's starting to step up. And that's what our part is going to look like after the first set of roughing operations. So from here, I'm going to exit verify. I'm going to make the solid model that represents the material and the stock model that represents the material invisible. So I'll go to the toolpath manager, and I'm going to start by making this stock model invisible, or I'm going to turn off the display. I'll select this icon, and then the levels, I'll make the material level invisible. And I'm now going to create a stock model that reflects what these two toolpaths have done. With the insertion arrow at the very end of the toolpath group, I'll go to stock model. And I'll call this rough half inch or rough half inch tool. for the initial stock shape. What did the part look like prior to these two toolpaths? So they looked like a stock model that we created for the raw stock. And then go to source operations. Which toolpaths did the work? So hold the shift key down and select both of the roughing toolpaths that we just created. Select OK. Mastercam will take a moment to process it. It's going to create a stock model that we can use for following toolpaths that reflect what these two toolpaths have done. You can still see that it's spooling or processing. At this time I don't need to have the boundary visible, so I'll go to my level manager and I'm going to make the solid model level visible, solid model level active, and the boundary invisible. And there you can see the stock model that reflects what the two roughing toolpaths have done. And we can compare what the current state of the material looks like relative to the part. And you can see that we've got some areas underneath the chin, inside of the pedestal or the base, that the previous tool couldn't reach. So what we're going to need to do is we're going to need to come in with some smaller tools and remove this material before we start doing our surface finish toolpaths. So from here I can make the stock model that we just created invisible. And what I would like to do is I'd like to see how these two programs post out. So I'll select the entire first operation toolpath group and I'll select the G1 icon. I'd like to see what's going on with the A axis. So from here I'll accept the defaults, I'll select OK, and I'll accept the default name, and it's going to open up Code Expert, and then we'll be able to see what is going on with our A axis rotation. It's taking a moment to process. And it doesn't let me do anything while it's posting out the NC file. So here's our NC file, and right away you can see an A0. So the left face construction plane, or the left face WCS, is going to establish our A0. And if I type in A and then find next, and we just shot past it, find previous. So here is our tool change for the right face, and there's our A180. So what it does is it retracts to 2 inches above the center line, but it's also creating a new work offset. So what I'll need to do, the first work offset is G54, and then the second work offset was G55. To fix that, what I need to do is I need to go back in the Mastercam, go to my Planes Manager, and for the left face, set it to manual 0. And then for the back face, manual 0. For the right face, manual 0. And then for the front face, manual 0. And this will force them, or force Mastercam, to assign G54 to all 4 orientations. So from here, I'll go back to the toolpath manager. I'll hit G1, I'll post it out again, and I did not have the Alright, Alright, now I have the toolpath selected. I'll select G1. OK. I'll just overwrite it. This is not the final NZ file. I'm just running a test to see what the post is doing with the A rotation. It's going to ask me if I want to overwrite. I'll say yes, or reload. So now we can see that we have a G54 with a 0. And then we have our rotation. It goes to 2 inches above the center line. It rotates 180 degrees. It does not call a new work offset. It does not call a new work offset, so this should work. So from here, I'll close out of the Code Expert. I'm going to make my stock model visible. From here, I'll save my work. And at this time, we're ready to create the follow-up toolpaths that get inside of these areas and remove the excess material.